Good afternoon, everybody. My name is Gabriele Capannini, as the chair said, and what I'm going to present is the result of a preliminary research conducted in the context of the visibility-based emergency stop system for smart industries, as written in the title. This work is a part of a research project funded by the KKS Swedish Foundation, and this type of project aims to promote the collaboration between companies and universities in different research areas. The author of this paper is me and Carlson, who is a colleague of mine at MDH, and Roger Mellander from ABB Robotics Departments, both located in Västerås, Sweden. During the presentation, I will make use of an example in order to introduce the theoretical and the more practical aspects of the problem, as well as the terminology I'm going to use. So the context of this work, as I told you before from the title, is a modern factory where humans, operator, and different types of machine cooperate together in the same environment. In this type of scenario, machine can vary from small moving vehicles, those who had a small harrow attached to them, to bigger stationary machinery like robotic arms, these kind of types. Moreover, the space can be considered, for example, could be an open space, or it could be divided in smaller areas by means of walls or a similar type of dividing structures. In such an environment, things can happen and can be the case where operator realizes that something dangerous is going to happen, and because of that, he wants to stop the machines in order to prevent any type of trouble. To this end, we imagine that each operator is provided with a handheld device, a kind of emergency stop button, that can be pressed in order to prevent this kind of trouble if something wrong is observed. The point is that what should we stop? Because if we intend somehow to stop all the machinery in a given area surrounding the operator, this operation could be almost inefficient or ineffective or too costly. For this reason, we designed a system which is working on the visibility principle, which means we attempt to stop only those machines that are visible from the bottom position, the emergency bottom position, according to the obstacle that can be present in the environment. In this case, the gray colored objects are those that are visible from the position operator, from the position of the operator. So to realize a system according to what we just said, we built a model based on the planar visibility problem, which is a well-defined problem in the area of I don't get the name. Well, it's a well-known problem. As this saying suggests, however, since this is a planar model, real 3D world objects are flattened in a 2D version of them according to the planar projection of these objects on the floor. So each projection is then enclosed in a convex and tight polygon, of which we know position and size. In addition to the original problem definition, by the way, we needed to add something which to better characterize the objects that are presented in this scenario. For example, if an object is short, like the vehicles that I showed before, probably this object let the operator see what happens behind them. And for this object, we say that the polygon is transparent. we define this kind of tag or field for the polygon or the objects. By the way, there are also objects that can be stopped, for example, a small robot or bigger machinery, while others, like the walls, there is nothing we can do. They are just a pure obstacle that limit the field of view of the operators. And to discriminate between these two type of objects, we added even a flag which is stoppable. To understand if an object can be stopped or if stop that object is meaningless or not. In this model, so okay, we define that an object is visible according to what definition that I wrote here. An object is visible only if it exists a straight line from the bottom position to any part of the object polygon that does not intersect any other non-transparent polygon or object. From now on, when I say polygon, an object is almost the same thing. So slide 4. Let's see now how our algorithm works. Okay, at the start, the algorithm needs to know the position of the operator of the query of the button, which is Q, and the set of polygons representing the objects. Okay, that are the red boxes in the figure. Okay, the first phase of the algorithm consists into defining which part of these red boxes that enclose the object are visible from Q. The theory says that this can be approximated by a segment which connects to endpoints, to vertices of the boxes. And this is a function of the polygon as well as of the position of Q. Okay, after this, since the next phase of the algorithm actually will be, as we see later, is going to perform an angular sweep of the segment surrounding Q. The first thing that we need to know is to sort this set of endpoints of the different green segments according to the angle that they form with the reference direction, which is the orange arrow I inserted here. You see, from the center, from the operator to 3 o'clock. You see, you should understand. Okay, and this angle is calculated considering Q, the origin of a polar coordinate system. Slide 7. Okay, and now the angular sweep start. Okay, now we should move a little bit faster. Okay. For each endpoint, which is the red dot which is in the slide, we fire a ray. And for each ray, we're going to intersect to analyze and to see what is visible in the set of objects that intersect the current ray fired. Okay? So now we just have J, which is the wall. Then, if we move to the next slide, now we have even F in the set of objects intersected by the ray, but F is not visible because J is between the operator and F. Yeah, as soon as the vertical wall ends, and it happens that both A and D get visible because D is transparent, and let's see the operator through it. And even the machinery A can be seen. If we take an analysis of the complexity of the algorithm, the most expensive part is the angular sweep, the phase number 3. And according to the data structure that we are going to use to collect the objects intersected by the current ray, we can have a different time complexity. The point is that in the end, the final complexity is at least quadratic in the number of objects to be considered. Okay. Despite the complexity, the algorithm behaves pretty well in practice, and it exhibits a trend which is linear instead of quadratic in the number of elements of objects considered in the scenario. On top of this algorithm, we even we built an emergency stop system, which consists in a server that essentially has the knowledge of all objects affecting the visibility algorithm and collect any change about them, change that are sent by the client. And the server is even responsible for computing the visibility set for the position of each emergency button. And then we have even a batch of clients that can be both machines and buttons, emergency buttons, that send their update to the server. And if the client is a stoppable one, they even are able to receive a signal in case it is sent by the server when the emergency button is pressed. With this architecture, we can actually build two types of services, and one can be, for example, a lazy one, where the visibility is calculated only when a button is pressed, or we can prioritize the reduction of the latencies, which means that every time the server gets an update, whatever type of update it is, we just recompute the visibility set for each algorithm, so that if the button is pressed, the result of the visibility algorithm is already available and can be immediately sent to all the clients interested. So the next slide is the last. Okay, this conclusion feature work. We are still working on this problem. Something has been done. We need to make more on-site experiment and to make even a kind of validation of what we got until now. And we got even some requests in order to enable some feature on this algorithm. So this is the last slide. If you move to the next, okay. Thank you for your attention. If you have any question, please.